So in this video, I'm going to break up the spring final exam review into two parts. There's just going to be 1 through 33, and the other video is going to be 34 through 63. So let's get going. So first of all, let's go ahead and read this first problem. It says the circle P is dilated to form circle P prime. Which of the following statements is always true? Well, the first thing I want to state is that we don't know how this was dilated. How it was dilated, okay? So that means we just know that it either got bigger or smaller, but we don't know how it got big. How, okay? It just changed size. So the first one, letter A, says the radius of circle P is equal to the radius of circle P prime. Well, we know that's not true because it dilated, okay? Then it says the ratio of the diameter to the circumference is the same for both circles. This would be true because if we have the diameter over the circumference, and it would be equal to 2 times the diameter times 2 times the circumference. So that ratio would be the same, right? So the answer actually is B, but let's talk about why C and D are not the answer. The diameter of the circle is greater than the diameter of circle P prime. Well, we don't know that because we don't know how it dilated, okay? The length of any chord in circle P is greater than the length of any chord in circle P prime. Again, we don't know that because we don't know how it dilated. All right, so number 2 says, if a circle A has center H, -3, and a radius of R, and a circle B has a center H2 and a radius of 3, which sequence of transformations should you apply to the circle A to demonstrate that it is similar to circle B? Okay, so on this one, first what we're going to do is we're going to look at the change in X and the change in Y. So these are our X's right here, right? So if we want to talk about the change in X, we're going to do H minus H, which means it didn't change at all. Okay, so it didn't move left or right. So we can go ahead and cancel that out, right? Now we're going to look at the change in Y. Okay, so these are our Y's right here. So I'm going to take the ending, which is, it says it went from A to B. Okay, so we're going to take the end, which is 2, and we're going to subtract from it the -3. Okay, so remind you guys that when you subtract the negative, you're really adding. So that's 5. So that means that it went 5 up. Now, if it was -5, it would have went 5 down, right? So this went 5 up. Okay, so there's our 5 up. It didn't go to 5 down. Okay, so now we're also going to check the scale factor. So when we talk about scale factors, we're talking about the dilation of what? The radius, right? So we want to look at our radiuses. So our radius, this was where we began, right? And this is where we ended. Remember, we always take the end over the beginning, okay? So that's going to be 3 over R, which is exactly what we have right there. So that's why our answer is, that should have been C, y'all. So for number 3, it says 2 circles are shown in the diagram. The circle with center B is dilation of the circle with a center A using a scale factor of 2. Okay, so it says which of the following statements are true? Select all that apply. So letter A says the circumference of the circle centered at B is greater than the circumference of the circle centered at A by a factor of 2. So circumference is equal to 2 pi r. Okay, so what we're going to do is we're going to find the circumference of each, and then we're going to compare them. So the circumference of the first one is 2 times pi times 6, that's our radius, so that would be 12 pi. The circumference of the second one would be 2 times pi times 12, so that would be 24 pi, right? And then we're going to compare them. So we're going to do the 24 pi divided by the 12 pi. The pi's cancel out. 24 divided by 12 is 2. So that's a true answer. It is greater than the circumference of B is greater than A by a factor of 2. Okay. Then it says the ratio of capital L to capital R is greater than the ratio of little l over little r by a factor of 2. So let's go ahead and compare that again. So if we do 8 pi over 12, that would be, 4 goes into both of those, so that would be 2 pi over 3 for capital L over capital R. Now if we do that also for, then we got 4 pi over 6, again 2 goes into both of those, So that would again be 2 pi over 3. So it says the ratio is greater. That's not true. These are the exact same numbers. So this one's not true. The next one says the value of beta is greater than the value of sigma by a factor of 2. So that's not true either. Now, how do I know that? Because the angles are the same. And I know that because when we are to multiply these, we're going to get the same. If this is 4 pi and that's 8 pi, it means that these are a factor of 2. You see that? And that's the length of these arcs. Okay, so if the length of the arcs is bigger by a factor of 2, then obviously the angles have to be the same. Okay, so this is not true either. Okay, that's the same angle. So we could say same angle here. The next one says the angle marked sigma measures 4 pi over 6. And we know that that's true because we computed it up here, right? Wasn't it up there? So that's true. The angle marked beta measures 12 over 8 pi. That's not true because, again, when we were to do it, this is what we got up here. Okay, so that one's not true. Number 4 says the circle with the center F is divided into sectors. In circle F, segment EB is a diameter. The length of segment FB is 3, so FB is right here, and FB would be our radius, right? So that means our radius is equal to 3. It says, which of the following expressions represent the arc length of arc AED? So we're looking for this arc right here, AED. So that means we got to find arc AE, and we got to find arc ED. Okay, so to find AE up here, I'm going to take 180 because that's half. That would be this right here, right? 180. And I'm going to subtract from it the 120, so that would give me 60. So this right there is 60, okay? Then on the bottom, similarly, I'm looking at this, okay? So hopefully you can see that when you add these two together, you get 75. So we're going to do, to find this piece right here, we're going to take 180 again, subtract 75, and that's equal to 105, okay? So now what we need to do is we need to add the 60 and the 105 together to get arc AED. Okay, so because this was right 105 right here, okay? So we want the blue arc, so we're going to do, we're going to say that theta is equal to 60 plus 105, which is 165. So then it's asking us for the arc length, and that formula is 2 pi r theta over 360. That's on our formula sheet. So we are going to multiply 2 times our radius, which we know is 3, times our theta, which is 165, and then divide all that by 360. And I'm leaving pi at the end because it's in all our answers. So when I did that, I got 990 over 360 pi, and that reduces to be 11 over 4 pi. So that was our answer, C right there, okay? Number 5 says circle Y is shown. What is the area of the shaded part of the circle? So this is asking for the area of the sector, right? Isn't that what it's asking for? So that formula is pi r squared theta over 360. Here's our r. Now it says the shaded portion, right? So if we want the shaded part of the circle, then we have to do 360 minus our 75, right? To get that. And so this was 285 degrees down here. Okay, so that's going to be our theta. Make sure you're reading the questions. Okay, so again, pi's in all of our answers, so I'm going to save that for the end. So I'm going to do 9 squared times the 285, divide that by 360, and leave our pi on the end. So when I did this one, I got 513 when I reduce it over 8 pi. And that would be centimeters squared. So that would be D down here. Number 6 says an apple pie is cut into 6 equal slices as shown. If the diameter of the pie is 10 inches, what is the approximate arc length of one slice of pie? So we don't use diameter. So if the diameter is equal to 10, we know that the radius is half of that, right? So we're going to divide that by 2, so our radius is 5. And then we need to find the theta, right? So to find theta, we're going to take our whole pi, which is 360, and divide it by 6 because it's 6 equal pieces. That's going to give us 60 degrees. Okay, so now all we have to do with that is, again, we're looking for arc length. So we need this formula, L equals 2 pi r theta over 360. So that's going to be 2. This time we are going to multiply by that pi because notice there's no pi in our answers. So it's going to be 2 pi times our 5 times our 60, all divided by 360. So when we do this one, we get 5.24 inches. And there it is. Okay. So number 7 says, what's the length of minor arc AB? Okay, so here again, it's asking us for this arc right here, and it's an arc length, so L equals 2 pi r theta over 360. There's our r, and there's our theta. So we're going to do 2 times our 4 times our 56 divided by 360. And remember, that pi is still on there, right? So when I did this one, I got 56 over 45 pi. And remember, when you guys are doing this in the calculator, if you're trying to get it, get the fraction to its simplest form, if you're using the TI-30s, then you need to put it in math print mode and do N over D. If you're using a TI-84, you need to do, when you have your decimal, you need to do math, push the math button and then enter, okay? So there's our answer there. It says, what's the area of the shaded part of the circle? So here again, we're going to do 360 minus the 80 to get this part right here. And so this is 280 degrees. So that's going to be our theta. There's our r. So again, we're using area. So this is pi r squared theta over 360. So we're going to do, I'm going to put all the answers for this one, okay? So this is going to be 3 squared times 280 times pi divided by 360. Now I'm going to leave pi out to begin with so that we can write that answer. And this time it's 7 pi, and this is centimeters squared. And then when we compute that, that's our approximate answer. That's 21.99, again, centimeters squared. I don't know why it did that, but let's fix it. There we go. Okay. Number 9 says, an amusement park has discovered that a brace that provides stability to the Ferris wheel has been damaged and needs work. The arc length of the steel reinforcement must be replaced between 2 seats below. So they're talking about this right here. Actually, let's mark it. This right here. See that? The sector area is 2825 square feet. The radius is 12 feet. What's the length of the steel that must be replaced? Okay, so it's telling us sector area here, so that's key. So that's the formula, pi r squared theta over 360. Okay, so we know that that area is 28.25, and this is our radius, right? So that's going to be equal to pi times 12 squared times theta divided by 360. Okay, so we need to go ahead and solve this. So what I'm going to do is I'm going to multiply both sides by 360. Okay, so that I can get rid of that from the denominator. And when I do that, I get 10170 equals pi, and I'm going to go ahead and compute that 12 squared, that's 144. And our theta. Now we're going to divide both sides by 144 pi. That's going to leave me just with my theta, okay? And you can do that in your calculator, but you might need to remember to put this in parentheses, okay? Because if you don't, when you divide it, it's going to divide by 144 and then multiply by pi, okay? So be careful. So when I did that, I got theta equals 22.48 degrees, okay? So now what we want to do, because it's actually asking us for the length, it's asking us for arc length, okay? So it wants us to tell, they want to know how much material do we need for that blue right there, okay? So that's going to be L equals pi sorry, 2 pi r, 2 pi r theta over 360, right? Okay, so that's going to be 2 times, this time we are going to multiply by pi because we need to know how many feet that is, right? So 2 pi times our radius, which was 12, times our 22.48, and dividing all that by 360, okay? So when we do that, we get the length is equal to 4.71 feet. Now, this right here would be the type of problem that I would expect to be on the final if we had a question like this, okay? Because we have to put both pieces together. We have to put the area of the sector together to find theta along with the length when we have to plug back theta, okay? So this is the type of problem that you guys need to be aware of. You should be looking for on the final, okay? So you might want to star it. Okay, so deriving the equation of a circle. So first we got our radius, right? So the radius is equal to what? So you know what, let's just go ahead and write Pythagorean's theorem first. So Pythagorean's theorem is a squared plus b squared equals c squared, right? Where this is a leg, and this is our hypotenuse, right? Okay, so what we're going to do is we're going to plug these now into our formula, right? So our hypotenuse is going to be our r. Actually, let's do that in red, okay? Then I'm going to create a horizontal leg here, and this is going to be x minus h, isn't it? So that's going to be my x minus h leg, so that's squared, plus what? Our other leg, right? So this is our other leg down here. That's our vertical leg, and that's going to be y minus k, okay? So that's going to be y minus k, and again, that's going to have to be squared. And that's going to be equal to what? Our r squared, right? Why? Because that's our hypotenuse. So this is a right triangle. See here, remember our radius is across from our right angle. So what you need to remember here is that x minus h squared is a leg, y minus k squared is a leg, and r squared is the hypotenuse, okay? 11 says the radius of the circle is 6 inches, so r is equal to 6. What is the area of the sector bounded by a central angle measure of 120? So theta is 120 degrees. And our formula is area is equal to pi r squared theta, because it says sector area, right, over 360. So we're just going to populate this formula, pi times our 6 squared times our 120 divided by 360. When I do that, I got... Oh, and it says to leave the answer in terms of pi, so I just do 12 pi here, okay? And it would be inches squared. So number 12 says which circle has a center of -2, 3, and a radius of 3. So I'm going to put this in the equation of a circle, x minus h squared plus y minus k squared equals r squared, knowing that this is my h and this is my k because it's the center, and this is my r, okay? So we're going to put it in there. So it's going to be x plus 2 because it's minus a minus, plus y minus 3 squared equals 3 squared, which is 9, okay? So now I'm just going to actually do this. I'm going to use the box method here in 2. So x times x is x squared, 2 times x is 2x, and then 2 times 2 is 4, and we got another x times 2, so that's going to be another 2x plus 4. Going to do the same thing with this y minus 3 over here. So I'm going to do y and -3. So that's going to be y squared minus 3y minus 3y plus 9. And okay, so now we're just going to combine what we have here that are like terms. So we have x squared plus 4x plus 4 plus y squared minus 6y plus 9, and then we have that other 9 on the other side. So those 9s are going to cancel each other out, right? You guys see that? So we're going to end up with 0 over there. So now I just want to look and see which terms are the same. So we got an x squared and an x squared. So we don't have the 2x squared. We don't have the 3x squared, okay? And then I have a 4x. Everything's the same here, notice, but these two numbers and the other two. Okay, so what do I left with right here? That 4. Okay, so that's why the answer would be A. So to me, the easiest way to do this is just expand the equation till you see which one matches over here. Okay, so number 13 says identify the center and radius of each circle. So on this one, remember, we're going to put all our x's in one set of parentheses, all our y's, and we're going to move our constant to the other side. Well, it's already over there today on that one, so we're good. So we're going to put our x squared here plus our 12x, create a blank, and create a blank over here as well. Then we've got y squared plus 4y plus blank. Okay, now we're going to take that middle term right here, that coefficient, 12, and divide it by 2. That gives us 6, so that's going to be x plus 6 squared. Then we're going to square that term, and we're going to put it back up in the blank, and we're going to put it on the left of the equal sign and the right of the equal sign, okay? I didn't put that other blank over here, did I? Okay. So now we're going to do the same thing with the 4. So we're going to take the 4 right here and divide it by 2. So that's going to give us y plus 2 squared. Okay, and then we're going to square that term and stick it back up there as well. So that's going to give us 4. Okay, now we need to combine all those terms on the right side of the equal sign. So when I did that, I got 17. Okay, so now we need to find the center and the radius. Okay, so the center, remember when we pull our center, because the equation is x minus h and y minus k, we're always going to change the sign. So our center is going to be -6, -2. And when we find our radius, we're going to take the square root of whatever is on the other side of the equal sign, because this is equal to r squared right now, right? So what we want to do is take the square root of 17, and that is our radius. Okay? All right, so the next one, same thing. Okay, so we're going to, again, create a set of parentheses, 2 sets of parentheses. And on this time, I am going to move that 30 to the other side, so I'm going to do that by adding it. So it's going to be a positive 30 over there. So we got x squared plus 6x plus blank and plus a blank, right? And then we're going to do y squared minus 10y plus blank plus a blank right there. So again, we're going to take our 6 right here, divide it by 2. That's going to give us 3. So that's going to be x plus 3 squared. We're going to square that and put it back up in that blank. Okay. And again, do that on the other side as well. So we are going to take the -10, divide it by 2. That gives us -5. So that's going to be y minus 5 down here. And then we're going to square that. -5 times -5 is 25. So we are going to put the 25 up here in that blank as well. So when I add up all 3 of those numbers this time, I get 64. Okay. So once again, when we pull our center, remember what we're going to do. We're going to pull the numbers that are opposite of what's there. Okay. So our center is going to be -3, +5, and then our radius, we're going to take the square root of 64, which we know is 8. All right, number 15, it says the picture shown is a circle divided into 8 equal wedges, which are rearranged. The radius of the circle is r, and its circumference is 2 pi r. Okay, so if the radius is r, then we know that this right here is r, right? Okay, and then if we know that, it says, how does the picture help us explain why the area of the circle is pi r squared? So circumference is 2 pi r, right? So the radius of the circle is r, and its circumference is 2 pi r. But look, we've only got half the circumference here, so it's because it's 1, 2, 3, 4. Y'all see that? So this is actually only going to be pi r because it's only half the distance around the circle, okay? So then it says, how do we explain the area? So don't we normally do area by length times width? So that's exactly what we're going to do. We're going to do pi r times r. So the area is going to be equal to pi r squared. So that's the explanation as to why this is true. All right, the next one says solve for the indicated angle or arc measure. So this first one, we're going to do outside arc minus inside arc divided by 2, and that equals the angle, okay? Now I see a problem because I don't know the outside arc. So we need to take the 70 and the 110 and subtract them from 360. So 360 minus 180, isn't that 70 plus 110? So that's 180. So we're going to go ahead and label this part out here 180. Now we can do our problem. So we're going to do 180 minus our inside arc, outside arc minus our inside arc, 70 divided by 2. So that is 110 divided by 2, which is 55 degrees. Okay? So our next one, number 17, if you recall, whenever the angle is on the circle, this is what we call an intercepted arc. We just have to take the arc and divide it by 2 to get the angle. So angle X is going to be 160 divided by 2, which is 80 degrees. All right, the next one, again, we got our outside arc minus our inside arc. So once again, we don't know what our outside arc is, and we've only got 2 arcs. So we're going to take the 360 and subtract from it 142. And when I did that, I got 218. So this is 218 out here. So once again, we're taking the outside arc minus the inside arc, 218 minus the 142, and dividing that by 2. So when I did that, I got 76 divided by 2, so this is 38 degrees for the measure of angle D, okay? Because it was asking us for that angle right there. All right, so the number 19, you may or may not recall that when we do arc plus arc divided by 2, we get that angle right there. Okay, so we're going to find that angle, and then we're going to use the straight line to find x, okay? So we're going to add 112 plus 178, divide that by 2, and when I added 112 to 178, I got 290. Divide that by 2, so our question mark angle is 145 degrees. So I'm going to go ahead and reset a question mark, and I'm going to show y'all. When I have the 145 here, then that angle and x, don't they form a straight line? Y'all see this straight line right here? What's the measure of a straight line? 180. So to find x, we're going to do 180 minus the 145. So x is going to be equal to 35 degrees. Number 20, again, we got outside arc minus inside arc. So we got outside arc here minus our inside arc there, divided by 2 is going to be equal to the angle E right here. That's what they're asking us for. So we're going to do 110 minus the 30 divided by 2. 110 divided by minus 30 is 80. So this is 80 divided by 2, which is 40 degrees. All right, so 21 says a cone and a cylinder have the same radius and height. The volume of the cone is 100 pi, or 100, yeah, that should be pi, y'all. I don't know why it has a question mark there, but that's 100 pi cubic feet. What is the volume of the cylinder? A square pyramid and a square prism have the same relationship if the base and heights are the same. Okay, so cylinder and cone, so pi r squared h divided by 3 is the volume of a cone, right? So that's our cone volume. And then a cylinder is what? Pi r squared h. So it's saying the volume of the cone is 100 pi. Okay, so if the volume of the cone was 100 pi, what would we have to do to the cone to get the volume of the cylinder? Wouldn't we have to multiply this right here by 3 to make it equal to that? We would. Okay, so that's exactly what we're going to do. So we're going to go 3 times the 100 pi. So that is 300 pi. Okay, in feet cubed. Make sense? Okay. The next one says a rectangle will be rotated 360 degrees about a line that contains a point of intersection of its diagonals and it's parallel to a side. It says what three-dimensional shape will be created as the result of the rotation. So what I want to do is draw a rectangle, and then it says that it would be rotated about the point of the intersection, okay, so of the diagonal. So there's a diagonal, and there's a diagonal. So we're going to rotate about that point right there, right? So if we rotate about that point, what shape are we going to get? A cylinder, right? And that's because now this becomes round, doesn't it? So it is a cylinder. All right, number 23 says a pyramid has a height of 5 inches and a volume of 60 centimeters. Which of the following figures could be the base for this pyramid? Select all that apply. Okay, so we know it says the pyramid has a height, h equals 5, and a volume. So the volume of a pyramid, okay, is equal to the base times the height divided by 3. Okay, so we have the height and we have the volume. Okay, so we're going to say 60 equals the height base times 5 divided by 3, right? So we're going to get rid of that 3 by multiplying both sides by 3. So that's going to give us 180 equals 5 times the base. We're going to divide both sides by our 5. So that means that our base has got to be equal to 36. So what we want to do now is look and see which of these is equal to 36. So a right triangle with a side of 5 and a hypotenuse of 13. So this one would be, okay, let's draw this one. So we got a 5, a 13, so we need to do 13 squared minus 5 squared to find this one, right? So that would be 169 minus 5. Sorry, 25, that would be 144. Take square root of 144, that's 12. Just means our sides, so 5 times 12 is equal to 60. So that one's definitely not our answer, okay? And then it says a hexagon with an area of 36 square feet. So that's what we need, right? 36 square inches, sorry. And then a square with side lengths of 6, that would be 6 times 6, that would be 36. So that one also works for us. A rectangle for 3 times 4, that's 12. So that one does not work for us. 4 times 9, a rectangle, length times width, right? So that's also 36. So there's another one that works for us. And then a circle with a radius of 4 inches. Well, that would be pi times 4 squared, which would be 16 pi. And that's definitely going to be more than 36. So 16 times 3 is 48. Okay, so that's definitely not it. Okay, makes sense to everybody? All right, number 24 says the height of a right cylindrical canopy is greater than the diameter of the base of the can. The can is sliced into 2 equal parts through its bases. Which of the following best describes the cross-section of the cylinder? Well, that's just wordy, but we're just basically asking us if we cut the can in half, what shape from top to bottom, what shape do we get? We get a rectangle, don't we? Okay. Number 25 says a right circular cone is shown. Which of the following figures could not be a cross-section of the circular cone? Well, obviously, if we went straight down through the middle, this would be, I'm quite sure it's B, but if we went this way, we would get the circle, right? If we sliced it this way, we would get an oval, okay? All right, it says, what is the area of the shaded region of the diagonals if the diagonal of the square is 7 square root of 2? So if this diagonal right here is 7 square root of 2, then look what we have. We have a right triangle, don't we? Okay, so do you remember that the hypotenuse is equal to a leg times the square root of 2 for a 45, 45, 90 triangle? And how do I know this is a 45, 45, 90 triangle? Because these angles have to be congruent because these sides are congruent, right? Okay, so that means if I know that the hypotenuse is 7 square root of 2, then these are both legs, right? So that would be the leg square root of 2. So I can divide both sides by the square root of 2 here, right? So our leg is equal to 7. So both of these are equal to 7 and 7. Well, actually, all 4 sides are equal to 7, right? Okay. So then it says, what is the area of the shaded region if the diagonal of the square is, okay, so first of all, the area of the shaded region. So that means we want everything outside the circle. So we need to find, so if this whole thing right here is 7, then what is this part right here from there over, which is our radius, right? That would be 3.5, wouldn't it? Because we would divide the diameter by 2. Okay, so our radius is equal to 3.5. So I'm going to find the area of that circle. So that's pi times 3.5 squared. So when I do that, I get 38.48. And then when I find the area of the square, that's 7 times 7, which would be 49. So what I need to do is subtract that 38.48 from the 49, don't I? So 49 minus 38.48 is equal to 10.5 feet squared, because it's area. Okay. Then it says, what is the formula for area density and for volume density? So when we're talking about area density, we're talking about things, okay? So I'm going to say the number of, I don't know what, something, fish, animals, rocks, whatever. There's a lot of different things you could do here. And then you're going to divide that by the actual area because it's area density, okay? Now when it's volume density, this time, you guys know this from chemistry, it's mass divided by volume, okay? So you got to really read the problem with these. Is area density we're looking for, or is it volume density, okay? So either way, you're going to divide by the area or the volume, so it's this word area and volume that's really key. It says there are 36 goldfish, there's our number of question marks, that live in an aquarium that has the dimensions of 4 times 3 times 2. What is the density of fish per square cubic meter? So fish per, okay, so that means fish go on top, and cubic meter, meters cube, isn't that area? So what we're going to do is take our fish, our 36, and we're going to divide that by our 4 times our 3 times our 2. Okay, and that's 24, right? So that's 36 divided by 24. So that means we got 1.5 fish per what? Meter cubed. Okay? So the next one says a forest area of 20,000 square feet contains 200 trees. Which of the following correctly represents the density of the trees in this area? Again, so notice the trees are first and then the area is second. Okay, so we're going to put our trees on top and our area on the bottom. Okay, so when we do trees, we got 200 trees, right? Over 20,000 area. So when we do that, we get 0.01. Okay, now if you put this in your calculator and turn that to a fraction, it's going to give you 1 over 100. And that's what? 1 tree per 100 feet squared, right? So that's why the answer is C. All right, number 30 says a square-shaped garden is being designed. A triangular region in the corner of the garden will be covered with decorative rocks as shown. If it takes 1,400 rocks to completely cover the triangular region, how many rocks per square foot is in the region? So again, we're going to look for rocks over our area, right? Now this time we got to solve for our area. And it shows us that this is 8 feet here. This is a right angle there. If this is 45, that means that has to be 45. So these two sides have to be the same. So to find the area, we're going to do the area of a triangle. So that's 1/2 base times height, right? Over our rocks, which was 1,400, okay? So that's going to be 1/2 of 8 times 8. Again, 1,400 divided by that. Okay, so that's going to be 1,400 divided by 32, which is 43.75 rocks per what? Feet squared. Because that was feet squared, wasn't it? Okay, the next one says a machinist creates a solid steel part for a wind turbine. The part has a volume of 1,015 cubic centimeters. The steel has a density of 7.95 grams per centimeters cubed. What is the mass of the steel part? Okay, so remember, density equals mass over volume. This one's got a volume, right? So it tells us the density is 7.95, and that's going to be equal to, and it's got our volume, so we're looking for our mass, right? So we're going to look for grams because that's what's right there. Over what? The 1015, right? Because that was our, and that's centimeters cubed. Y'all see that? Okay, so now how do we get rid of something in the denominator? We multiply both sides by it, right? So we're going to multiply both sides by the 1015. And when we do that, we get that our mass, our grams, is going to be 8,069.25. And this is going to be grams. And how do I know that? Because it's right there. Okay, the next one says use the following information for questions 32 and 33. A bakery sells hollow chocolate spheres. The larger diameter for each sphere is 4 centimeters. The thickness for the chocolate of each sphere is 1/2 inch. Okay, so if the whole thing is 4 inches, then I know the radius is going to be equal to 2, right? So that's for the outer part of the sphere. So what we're going to do here is we're going to find the outer sphere, and then we're going to find the inner sphere, and we're going to subtract the inner sphere from the outer sphere because the white part is now gone, right? So then if we were to find the radius right here, wouldn't it be, it says the thickness is 0.5, right? So that's 0.5. So if I subtract 0.5 from 2, I get 1.5, don't I? So that's the other radius. So what we're going to do now is we're going to find the volume of the outer one with our formula for a sphere. So that's 4/3 pi times 2 cubed, and we're going to subtract from that our 4/3 1.5, sorry, pi, skip the pi, sorry, pi, and then 1.5 cubed, okay? So when I did this, I got 33.51 here. And for the other one, I got 14.14. So we subtract those, and we get that the volume, or how much chocolate it takes, basically, is 19.37 centimeters cubed, because that's what it's asking us. The amount of chocolate in each hollow sphere, okay? Then it's asking us if the density of the chocolate is 1.309 grams per centimeter cubed, what is the total mass of one chocolate sphere? So we're going to look for mass again. So density is equal to mass over volume, right? So we have our density. That's 1.308, and that's equal to our mass over our 19.37, okay? So once again, we're going to multiply both sides by that 19.37, okay? And so when I did that, I got 25.34, this is going to be grams again, is our mass.